now we are turning to the last speaker of this session, and I will see if I can pronounce your name correctly. Please come up here, Sinan Özkavukçu. Please correct me if I'm wrong. I'm sorry.
Terrible, sorry.
Okay, thank you very much.
Never mind.
You are extremely well educated and have been in New York and worked on several clinics there, and you have been to Dunedin and worked with our good friends up there, and so you came back in 2023, is now professor in Ankara Medipol University, and you are going to talk to us about CHIPS, robust embryologists who will survive. So you have the last 20 minutes for that. Thank you very much.
Music. Thank you, Mr. Chairman, and I want to thank you, the organization committee, for inviting me to give this talk. So my talk is about different from the previous talk because it is like using AI to predict the haploidy or to select embryos. But this talk is much more about some mechanical or hands-on practice that will be replaced or not by the robots in near future. I have no conflict of interest to declare. So I'd like to start giving examples from car industry. So in this, the first picture on the left-hand side belongs to 100 years ago. So at those years, there was almost 3.5 people working per produced car. So in 100 years past, it decreased almost 100%, now reduced to 0.2 or 2.25 people that has to work per car in these factories, and robots replaced those people, and we will see if this is going to happen or not in embryology labs. So why do we use robots, and most necessarily why we should or shouldn't use them in IVF labs? So the learning period or the education of a clinical embryologist is, it's a very long time, takes a very long time. So more than 10 years of education, 3 years experience, 50, 100 repeats of procedures to get competency. But robots don't do that. So we need to eliminate human variability. We are all humans and we are prone to mistakes in the lab. So robots consistent on precision, they reduce human-induced mistakes in the lab, so they can be favorable. The procedures has to be standardized for all the patients. Patients really want that and deserve that. So robots can work in isolated boxes that provide controlled environment with reduced risk of contamination and fluctuations in the parameters inside the lab. And you can keep robots work all day long. So 24/7 operation time without tiring is what they promise. So flexibility in clinical procedures and embryology procedures is possible. And also better data collection and analysis will be done by artificial intelligence that run the robots. So my talk will be about general lab practice, mostly on culture dish preparation, because it is, I think, one of the most critical parts of the lab due to evaporation, and you need to be quick and accurate. Andrology, sperm selection, insemination, cryopreservation, and we will see what are the roles will change for the embryologists. So culture dish preparation, these the papers that I'm going to present are very recent. The most old paper would be a year ago. So this is one of the validation paper of a robot, a pipetting robot for the IVF lab called April. So it is a liquid handling robot, and the outcomes of the study was the droplet mass calculations between robot and manual operator, pH testing, and mouse embryo assay. So as you see on the left bottom graphic, 3 embryologists scored significantly lower in terms of droplet mass. So the variability and the deviation in manual preparation of the dishes was far inferior than the robot, which is blue, and I mean it is very precisely prepared by the robot. The pH values were close to each other between robot and the embryologist, but April prepared dishes actually had a higher rate of development on day 3 when compared to manually prepared dishes. Actually, the rates were higher on day 5 and in total blastocyst, usable blastocyst rates, but they are insignificant. So the droplet volume added to the dishes prepared by the robot was more uniform compared to those added manually, because when the researchers took the first dish prepared and the 20th dish prepared, and the rate of blastulation was, exactly the same when the robot prepared the dishes, which was close but not exactly the same in manually prepared dishes. So their conclusion was using robotics can free up embryologists' time and attention to focus on other functions for which robots are not ideally suited, maybe patient care and the other things, or research. With the global shortage of trained embryologists, robotics can help optimize their time. Another study for dish preparation actually gives more information to us. They found comparable fertilization and embryo development rates, but the researchers didn't like how the embryologists prepared the dishes. So as you see on the right bottom side of the slide, here, so the uniformity of the droplets were not good with the manually prepared dishes, but the A4 picture here, the robot-made dishes was totally uniform. And the most important data here would be the dishes, the time spent for dish preparation was significantly lower when compared to manually prepared dishes. The significant, not significant, but the significant outcome here, which is not significant actually, was the measurement of the osmolality. Because the most important part in the dish preparation is to be quick, not to avoid the evaporation and change the osmolality values, because these days most of the labs are doing dry incubation and osmolalities change by the time, so the dish preparation is become very important, and the robot did very well, basically the same with the embryologists. The other innovation in the lab is the selection of sperm just at the time of ICSI. So this AI sperm selection for ICSI is on the market and can be used, and this allows embryologists to select the best moving sperm just during the ICSI. So motility, the most important criterion for live sperm selection. This is the only thing we can, detect on a sperm. If it is motile, it is alive. So advanced motility parameters could be challenging to distinguish two different sperm if they are moving better or not, because some of the parameters are not distinguishable to human eye, that we can only measure by CASA systems. But this software can track the sperm, and with the artificial intelligence and just tracking the database of the software, it can give us 3 options, 3 best moving sperm, and the operator can select among these sperm. So this study is the latest and one of the only studies, prospective studies about this software. So it contains 650 sibling M2 oocytes randomly divided, and one of the groups were ICSI manually, and the second one was the sperm was selected by AI and injected by the embryologist, and the results are comparable when you do it with the embryologist or the sperm is selected with the software. There is no significant difference in outcome. So this tells it is not inferior than human selection. But most importantly, what they found is if they divide embryologists into two groups, senior and junior embryologists, the junior embryologists, when are assisted with this software, had score better fertilization rates, and even senior embryologists had better embryo development and top quality blastocyst rates when the sperm are selected with the AI. And when we come to insemination, you know, the most challenging or complex procedure in the lab is the sperm injection, ICSI. So we have many factors for the successful fertilization, like cumulus cell removal technique, timing of the procedure, how you do the procedure, the operator experience, the tools, needle exposure during ICSI, polar body positioning, and sperm deposition site were all published for the successful fertilization. Let's start with oocyte denudation. So there are two technical papers out using chips that this chip technology, you have to run the cumulus oocyte complexes through funnels that have zigzag-shaped lines. Looks like a little bit crushing the embryo, the oocyte. And another paper came out recently using the pipetting and automated algorithm. But one of the, I think, most interesting one in this field is using acousto-hydrodynamic tweezers, the sound, to remove the cumulus cells, do the denudation. So significantly decreased denudation times are achieved. So reduced need for hyaluronized enzyme concentrations are found, and comparable embryo development and delivery rates are there. Or there is only one safety issue that during denudation there is a slight increase in the heat, but I mean, considering that the average denudation of one COC is less than 0.8 seconds, that could be negligible. For the ICSI, yeah, we have automated ICSI, and the paper came out with the first babies conceived. So this paper just explaining the robot that was engineering doing all the injection, and they had 5 outcomes with some preclinical studies, arms, and also a clinical pilot trial in human donor oocytes. So ICSI pipette motion control, zonopellisuda, and injection is done with piezo pulses, and oocytes analyzed by artificial intelligence. Even the sperm immobilization, capture, and cytoplasmic release was done manually by a non-ICSI expert engineer. So let's take a look at the results of their in their paper. So in the mouse model, they did ICSI, the oocyte survival rates were comparable, the embryo development rates are comparable, blastocyst cell counts were comparable, but somehow parent-offspring cannibalism was found in 2 cages from automatic ICSI group. This was not put into comparison, and it was not very much discussed in the paper. The other outcome was they injected human sperm into hamster oocyte, and they checked the oocyte survival rates, and it was also comparable when you do it manually. The other outcome is the rabbit model. The rabbit model, they injected the oocytes, and the survival rates are comparable, and the embryo development rates are also comparable with the manual control. They also injected beads into human oocytes and checked the oocyte survival rates 2 hours later and overnight, and they are also comparable. Finally, they injected human sperm into the eggs. Two healthy live births achieved, but there is a small, drawback here. So manually done ICSI euploidy rates were significantly higher than the automated ICSI euploidy rates. So they concluded that sperm selection bias, where embryologist versus engineer could cause that. So this is the presentation in their paper. So they go in, do piezoelectric pulses, and release the sperm and go up. So there are vitrification papers coming out. These are kind of technical papers, but showing a good development and survival rate against control. But already we have a vitrification device on the market, Gavi. So a randomized multicenter open trial comparing a semi-automated Gavi with a manual open system is out in the literature. So it was a non-inferiority trial, prospective, but they vitrified 2PN zygotes. The results are totally comparable. Clinical pregnancy, outgoing pregnancy, and live birth rates are the same when they compared cryotop method with Gavi. However, the time took to vitrify and warm embryos is longer when you use Gavi, and when they make a questionnaire, the respondents said that these are embryologists. They preferred cryotop method, so they responded that Gavi method was not easier to use, not time-saving. 4 out of 8 respondents would not recommend the Gavi. And there are some other papers came out using this technology. So finally, we have Conceivable Life Sciences. This company actually built, and it is, I think, on the market or just going out, that they actually built all the series of procedures that can be done in an IVF lab. So you can watch the video. A longer video is available on their website. So dish preparation, sperm preparation and selection, IVF, ICSI insemination, handling, incubation, cryopreservation. So you give the COCs and you take out the selected embryo to be transferred or cryopreserved vitrified embryos. So this is coming to our labs, and we will see what it will change in our practices. So conclusions: integration of microchips and microfluidics in the IVF lab may allow precisely controlled fluidic manipulations. It will be timely and less toxic. It will provide better environment for the culture and embryos. So instead of clean rooms, we will build clean boxes for the robots to work in. So omics integration could be easier. AI integration could be easier. So minimizing human variability, standardizing procedures, enabling real-time decision-making with AI may seem revolutionary, but I mean, we discussed that in the morning sessions also. These has to be proven, and therefore good comparative studies need to be conducted against conventional methods. Cost effectiveness is an issue. It will be very expensive in the beginning, but long-term efficiencies, we really don't know about it. So I started with car factories. So I want to end my presentation with the cars. So I found this paper. It is very recently published, and they compared autonomic driven cars versus human driven cars. And they checked the accidents and compared what kind of accidents humans or robots are prone to. So what they found are very interesting. So the autonomous vehicles involve in fewer conventional and unexpected accidents. So that what I mean is, so you are just going on your road on the highway, so the car stop in front of you, the AI-driven car can detect it immediately and can stop. So these kind of accidents, front stops or lane changes are less frequent when the cars are driven by the robots. That means long-term focus and strict adherence to procedures are easier for machines than humans. It is also the condition in off-road in extreme conditions because they react faster. But however, during driving at dawn or dusk, it is 5 times less, and during turning point management, it is 2 times less. In human-driven vehicles, they are safer in those conditions. So the objective of automation should be to enhance the abilities of embryologists, not to replace them. This enables the embryologists to focus on more complex and nuanced tasks, enhancing the overall quality of care rather than simply fulfilling routine labor. And we will be discussing it in next 50 years with maybe some other ethical procedures will be added. Thank you.
Thank you very much for this Brave New World introduction. It was very interesting. I certainly think that there's a lot of new things that we didn't expect is coming around our way, one way or the other. We probably just have to adjust to it. We actually have overstepped our time a little bit. Any burning questions? One question, if anybody wants. Okay, then otherwise I would say thank you very much. And say thank you to the audience for your patience and being around. So we'll terminate the session here. Thank you very much.